Okay, so yesterday you saw solving linear systems using identifying the slopes and using the y-intercepts to determine if there was 1, 0, or infinite amount of solutions. So we're just going to do a quick recall here. When the slopes are the same and the y-intercepts are the same, so when everything is the same, that means there's basically two lines and it's an infinite amount of solutions. So you should just fill that in right here. Infinite solutions. Okay. When the slopes are the same and the y-intercepts are different, that means that the lines are going in the same direction. So they're either both increasing the same direction, and that means that there will be no solutions. So if the lines don't cross, there are no solutions. And then the third situation is when the slopes are different. So when your slopes are different, that means your y-intercepts are also different, and it means that there will be one solution. So that's something from yesterday. You should reread your notes, maybe put a little note in your survival guide, and that'll help you. So let's just quickly do an example here. So we need to make sure that all equations are in y equals mx plus b form. And the first equation isn't quite in y equals mx plus b form. So what we have to do here is get rid of that 2 that's in front of the y. Well, since those two things are stuck together, you have to cancel out the multiplication, which means we need to divide each side by 2. So when we do that, I'll just do the work here on the side. We get y equals, well, negative 2 divided by 2 is negative 1, and negative 8 divided by 2 is negative 4. So now we can list the slopes and the y-intercepts. So the slope of the first equation that we just rearranged is going to be the number in front of the x, which is negative 1. The slope of the second equation doesn't look like there's a number there, but don't assume that it's a 0. There's a negative 1 in front here. Okay, so that's both slopes we notice are the same. So now we just have to work with the y-intercepts. Well, the y-intercept of the first equation is negative 4, and the y-intercept of the second equation is negative 2. So since both slopes are the same, that means that these lines will never cross. And if the lines never cross, that means there's no solutions. No solution for that one. Let's move on to question B. So for question B, the first equation is already in y equals mx plus b form, but the second one isn't. There's a multiplication going on between the 3 and the y, and to get rid of it, we have to divide everything by 3. So we end up with y equals negative 2 over 3x, because I can't divide negative 2 by 3 without getting a decimal, and I'd like for you to keep your answers in fractions. And 3 divided by 3 is 1. Since the slope for the first equation is negative 2 over 3, and the slope for the second equation is negative 2 over 3, this might mean that there's no solution since the slopes are the same, but remember that you have to keep looking for the y-intercepts. So the y-intercept of the first equation is 1, and the y-intercept for the second equation is actually also 1, since that's the number without the x. Since all information, the slopes are the same, and the y-intercepts are the same, you're basically creating two lines on top of one another, and that creates an infinite amount of solutions. So infinite solutions. And there's one more scenario. You'll notice that both these equations are already in y equals mx plus b. And I know that because the y is completely on its own. We're going to label some work here. So the m in the first equation is negative 3. And the b value is 3. The m value in the second equation is positive 3. And the b value is also positive 3. So when I analyze this, I notice that the y-intercepts are the same. But that doesn't matter. If the slopes are different, which they are, a negative 3 is not the same as positive 3. As soon as the slopes are different, you know that you're going to only have one solution. It doesn't matter that your y-intercepts are the same. So in this case, you're going to have y-intercepts of 3. So I'll quickly draw this for you. Here's a y-intercept of 3, but one of the slopes is going down and the other one's going up. So no matter what, you only have one point of intersection, one point where the two lines will cross. So that's a recall of what we did yesterday. Today we're going to remember that solving a linear system means to find the shared point. So you may want to highlight that or underline it. It's just very important to know that the shared point is where the two lines cross. So there's a couple methods that we can use to do this, but one of the methods we're going to use is graphing. So we can graph anything we want, and we kind of did this yesterday again, by converting all of our linear relations into sloped y-intercept form. If you don't remember what that means, it means that y equals mx plus b. Okay, that's what that means. Once you've graphed it and changed it into y equals mx plus b, you want to graph and label all your equations. So in this case, there'll only be two, but that's the second step. So I think we're just going to get started with an example, and we're going to try to solve, which means to find the point where they meet. We're going to do it with a graph. So when we do that, we have the first equation already in y equals mx plus b. So we're just going to label our m, which is -2, and we're going to label our b, which is also -2. Remember that the slope is rise over run, and we have to create a run here. So if there's no run, you're just going to put it over 1. First thing you want to do is start by graphing your y-intercept. So in this case, we're going to start at -2. And the rise means to go rise up or rise down. Well, in this case, your rise is negative. So we're going to rise down 2, and we're going to go to the right 1. So down 2 to the right 1. Okay, I can do that fairly quickly. You can pause the video if you'd like. Now to do the opposite, instead of going down 2 to the right 1, you're going to go up 2 and to the left 1. So make sure you use a ruler for this part. We really want a nice straight line going through all of this. Okay, and I want arrows going through the entire line. To label in this linear relation, I'm just going to call it A. So just go ahead and put an A beside this line. The next line is not in y equals mx plus b form, so we need to take care of that before we even continue. So we need to find y completely on its own. However, the y is attached to the 2. So we need to get rid of the minus x. To do that, we're going to add x on both sides. That cancels out the x's on the left side and leaves us with 2y equals 6 plus x. Y is still not on its own, so we need to divide every single thing by 2. When I do that, 6 divided by 2 is 3, and the number in front of this x is a 1. Now, again, this looks funny, so I'm going to change this, have the 1 over 2 in the front, and I'm just going to add the x at the end. They're both the same form, just one's a little bit easier to see. So we have to identify the slope, and we have to identify the y-intercept. Be careful, the slope is not in the same spot as the other equation. The slope is the number in front of your x. So in this case, it's 1 over 2, which means my y-intercept will be 3. So I can start my graph at y equals 3, y-intercept equals 3. And remember again that slope is rise over run, which means we're going to run up since the 1 is positive and run 2 to the right. So if I do that, and I do these points, if I continue this pattern, it's not going to cross the other line. So what I need to do here is make sure that I go the opposite way. So instead of going up 1 and to the right 2, I'm going to go down 1 and to the left 2. So when it says to solve, it means something's missing. And if you take a look at these graphs, once they are graphed, you can kind of see that an important point would be where they cross. And that point happens right here. So to label the shared point is to write down the coordinates of that point of intersection. So the coordinates of this point of intersection is x is -2 and the y is +2. So remember that x is first and then it's y. So it's really important to make sure that you label your points properly. So at the end, we just have to write a therefore statement, and all I want here is therefore the point of intersection is -2 and 2. So you're going to get really good at graphing and really good at identifying coordinates. So let's just go ahead and practice a few more examples. All of the first example is in y equals mx plus b form, so it makes it a little bit easy to graph. In order to label them, we're going to call one of them a, and we'll call the other one b. I'll get to that in a second. So we need to label the slope, and the slope in this case is -3, and the y-intercept is 9. So in order to be able to graph this properly, we need to start at 9. If you count them out, 9 is over here, and our slope is our rise over our run, but we need to create the run by putting over 1. So we're going to rise down 3 and run 1 to the right. So down 3 and 1 to the right. So if you keep going and just keep going as far as you really can, you're going to want to draw your line through these and label it with an A. Okay. Now to label graph B or equation B, you have to make sure that it's in y equals mx plus b, which it's not. So we need to isolate this 3y. That means getting rid of the -3x by adding 3x on both sides. Once I add 3x on both sides, then I can divide everything by 3. Okay, so that means that y equals 3 divided by 3 is 1, and 3 divided by 3 again is 1x. So the slope of that equation is the number with the x, which is 1, and b actually also equals 1. Remember that your slope will be your rise over your run, so you need to create your run by putting over 1. So if we start at +1, because that's the y-intercept, then we need to rise up 1, and go to the right 1. So if we keep doing that, you'll be able to probably see the point of intersection by now, but I still wanted you to draw a couple other coordinates to the left. So we'll go ahead and label this, or draw a line through it. Okay, so we're going to label this line as line B, and now we're going to label the point of intersection. So what we're going to write here is, on this graph, I can see that the x value is 2, and the y value is 3, which means, therefore, the point of intersection is 2, 3. And there's your therefore statement. You've labeled your point of intersection on the graph. You can also label your y-intercepts. So the y-intercept is 0, 1 for this graph, and it is 0, 9 for this graph. Since it's a y-intercept, you label the y values and the x values are 0. Next one, we have the first line, which is in y equals mx plus b. So we can say that the slope, I'm going to call this line A. So for line A, my slope is -2, and the b value is 4. Well, since the slope is rise over run, we have to make sure that we create a run by putting over 1. So we're going to start with b equals 4 by drawing that coordinate on your graph. And then we're going to rise down 2, since it's negative, and to the right 1. So down 2, to the right 1. You just kind of keep going. You could put, instead of going down 2 to the right 1, you can go up 2 to the left 1. And then you just have to make sure that you draw your line. So I'm just going to go ahead and draw the line here and label the equation with an A. Just making sure I labeled my equation at the top. There we go. And now for the second equation, it's we're just going to write that it's 3y minus 2x plus 12 equals 0. And to find the equation in y equals mx plus b, I want to make sure that the 3y is isolated. So we're going to have to add 2x on each side, but we're also going to have to subtract 12 on each side to cancel out the plus 12. So we're going to end up with 3y equals 0 plus 2x minus 12. And at this point, we don't need the 0. So I'm going to write this.